Okay, so here's the problem for today. Well, this video is rather a curiosity because I've never seen such a thing in my life. Well, we are going to calculate historical volatility in SQL Server. Okay, this is really quite a weird thing because normally you use Excel or some more sophisticated software. But okay, here's the deal. We have some time series, complete time series with prices of share of Morgan Stanley. Okay, so I'll just order it this in a descending way. Order by date price descending, so that you can see what's the latest price. So it's basically for the end of March. Okay. Well, we'll use one year data, 1 year of data. Okay, this is complete. It goes back like, I don't know, maybe 20 years or so. Okay, so these data are not interesting for us, but we don't care. Well, the exercise we are going to do is not that easy. If you have never worked with SQL Server in your life, this will probably be very hard for you, but for some experienced users it's not that bad. Well, to calculate volatility, we need prices, the price of a share and the price of a share day before. This is exactly what we have here, but not as we would like to have it. We would like to have one more column over here, which would contain the prices, okay, so that we can use a logarithm. I hope you know the basics of calculation of volatility, but believe me, you need a column over here. Okay, so here's the thing. We are going to create a table that contains that begins with this date, and second table that begins with this date. Why are we doing this? Well, this is because you will see shortly that we will have the prices ordered in a special way. Okay, so let me just define or declare table 1 so what's the comment? I'm forgetting very simple things. Table, and now the columns. The columns will be, well, number, that will be integer, then date price, it will be date, and price, it will be float. And we will basically fill this table with the data we have here. Okay, this is not a temporary table, it's a variable table. It's declared as a variable. Okay, so let's fill it with data. So insert into table 1, and we will insert select something and date price and price from this thing, and we want to add here row number like this over order by date price descending. So it will actually create a very similar table, but with a column with integer number of the date. Okay, and just behind that put select everything from table 1. So as I said, we have this very similar table which has now this column and begins with this date. And likewise we define another table, declare table 2 with the same properties. Let's comment this out, and we will use the very same query, but under condition that where, forget to put number 2, where date price is less than select max date price from this thing. Okay, so what it basically will create, it will be almost the same table, but without this date as the first. Okay, and without this this price. Otherwise it will be perfectly the same table. So let's use this command so that we can see what it does. As I said, we are not having 30th of March over here. Okay, so now we have these two tables, and we now want to compute the relative change in price, which is described by a logarithmic function. Okay, so we will basically do the followings. We will type select logarithm of something from table 1 as T1, and we will choose the column T1 dot price divided by select let me think, it's not that easy. Select price from table 2, where let's call it as T2, where T1 dot number equals T2 dot number. Okay, so this mapping actually guarantees that we are matching the day and the day before for the logarithmic function. Okay, so you will see what happens now. I comment this out, and it will give us logarithmic differences. Okay, as log change, and we are now almost finished. Well, we have this. Forget the first first thing, it should be here. We have this thing, and we know that that volatility is the variance of the logarithmic changes. Okay, so sorry, it's not variance, it's standard deviation. So it will be select stdef from, here will be something, and we'll use alias as, I don't know, log table. Select stdef log table dot log change, and we also need to guarantee that we only have the top 255 observations, okay, because 1 year only has 255 trading days. Okay, so when I use this function, it will give me daily volatility. Okay, so this is daily volatility, and if I rescale it by 200, by the square root of 252, I get annualized volatility. So if I take the same thing times square root 252 as annual volatility, and we can multiply it by 100, to get it in percentage, in percent. Okay, and that's it. That's basically it. So the daily volatility of the share is 3.86%, which is quite high daily volatility, and annualized volatility, is 61%. Okay, it's just a rough calculation, but it works. If you want to verify this result, just go to Wolfram Alpha and look here. Morgan Stanley has volatility 61.6% according to Wolfram Alpha, and according to our calculation it's 61.40, which is quite close to sophisticated estimation. Okay, so this piece of code basically gives you nice estimation. Okay, so that's all from me now, and visit my channel again.